This is section 4.2, the mean value theorem. We can also call it MVT. The mean value theorem, let's put a box around this and star it. Says let f be a function that satisfies the following hypotheses. 1. F is a continuous function on the closed interval from a to b. 2. F is differentiable on the open interval from a to b. Then there exists at least one value c in the interval from a to b such that f prime of c is equal to f of b minus f of a over b minus a. The right side of this equation is the average rate of change, and the left side of this equation is the instantaneous rate of change. So we're going to go ahead and just look at what this visually is telling us. I'm just going to sketch a curve, and any curve, it doesn't matter, but we'll say this endpoint is going to be our A. So that means that the y value would be f of a. Likewise, we'll call the other endpoint B. And so this is going to be f of b. And so we have the slope from A to B. This is the slope of a secant line, which is f of b minus f of a over b minus a. And the slope of that is equal to some point in between A and B. And we'll call it C. And we'll just say about right here. And if you were to draw a tangent line at that point, you'll notice that those two lines are parallel. So this value that we have here is C. And so this says that the derivative at C is equal to the slope of the secant line between A and B. There's an example right below this that says if the hypothesis conditions are satisfied, find a point C satisfying the conditions of the mean value theorem given f of x equals on the interval from 1 to 5. The graph is given to us, but we're going to not look at that right now. Most of the time they don't give us a graph. So in order to do this, it does say that the conditions are already satisfied, so we don't have to check that it's continuous and differentiable. We can jump right into the problem, and the first thing that we need to find is f prime of c. I'm going to write an x though. It's just a variable. If you would like to use a c, you can. You can use any letter that you would like. And this is going to be equal to f of, and our interval goes from 1 to 5, so f of 5 minus f of 1 all over 5 minus 1. So taking the derivative of our function, it's going to become negative 2x plus 7 is equal to f of 5. If you substitute in 5 into your function, we get 4 minus, and if you substitute 1 into your function, you get 0 over 5 minus 1 is 4. And so we have negative 2x plus 7 is equal to, and that's 4 divided by 4 is 1. And then solving this, we're going to arrive at x is equal to 3. And so this value should be in your interval between 1 and 5, and it is. So we have when our value of c, or you can say x, is equal to 3. Again, whatever variable you want to use. The conclusion of the mean value theorem is satisfied. So taking a sec to look at the graph, again, most of the time the graphs are not given to you guys. This has the parabola that we were given. And you'll notice going from 1 to 5, which is given to us also. You can see the slope of our secant line. and then finding the slope of the tangent line, which would be our derivative, at the value of 3. And hopefully you can notice that